Welcome, Precalculus students, to another day in our unit on polar coordinates. So in our previous lesson, we talked about, we were introduced to this idea of how to convert a polar equation into a rectangular equation. So how to convert an equation written in terms of r and theta into an equation written in terms of x and y. So today we're going to do the reverse. Today we're going to be looking at rectangular equations and converting them to polar equations. Okay, so equations written in terms of x and y and rewriting those in terms of r and theta. Now, to recap, recall that in the previous lesson I talked about this idea that you want to make sure you know these four formulas and these are the same four formulas we use when we were converting points. When we're converting equations, these are the four formulas that we use in order to determine or in order to substitute in to the respective equation so that we can rewrite it in terms of the other variables. And another thing we talked about in the previous lesson was this idea that we know when we know when we're done with the problem when we've gotten rid of the appropriate variables. Okay, so once we've gotten rid of the appropriate variables, we know that we are done. All right, so let's look at a few examples. If you recall, last time we actually skipped over a few because I was saving them for this lesson. So E and F. So y is equal to negative 1/2 x minus 2, and y minus 4x is equal to 3. All right, so let's see what we can do with these equations to rewrite them in terms of r and theta. So right off the bat, we have, if you recall, we have formulas for x and y, right? We have a formula that says x is equal to r cosine theta, and we have a formula that says y is equal to r sine theta. So those are the two formulas that we're going to be using for both of these problems. So let's make their respective substitutions. So y becomes r sine theta, right? So y becomes r sine theta, and x becomes r cosine theta. X becomes r cosine theta. All right, so once again, y just became this, and x just became this expression. Okay, so pretty straightforward. And at this point, you can argue that we're done, right? We've gotten rid of the x and y variables, and now our equation is just in terms of r and theta. But let's just pretend the question was asking us, we'll solve for r, get r by itself. Let's take it one more step forward, and let's say that was the question. So solve for r, all right? Now, I'm not saying you'll always have to do this, but let's just pretend that's what the question ultimately asks us to do to get that r by itself. Well, let's see. We have an r on the left side of the equation. And we have an r on the right side of the equation. So what we're going to do is we're going to get those two r terms on the same side. So we're going to take this negative 1/2 r cosine theta, all right, and we're going to add 1/2 r cosine theta to both sides. So sorry about that. So r sine theta is equal to negative 1/2 r cosine theta minus 2. So once again, we're going to add that to both sides. So 1/2 r cosine theta, 1/2 r cosine theta. Okay, so if we do that, we end up with r sine theta plus 1/2 r cosine theta is equal to negative 2. So why does this help us to get r by itself? Well, this helps us because what we're going to do next is we're going to factor out an r. We're going to factor out an r from both these terms because they both have an r, right? So think of factoring. Remember, you factor out a common term or variable in this case. And we end up with sine theta plus 1/2 cosine theta is equal to negative 2. So now we have a single r. We used to have two r's, now we just have a single r. Well, now to get r by itself, we would just have to divide both these sides by sine of theta plus 1/2 cosine theta, sine of theta plus 1/2 cosine theta. So our final answer with r by itself would just be r is equal to negative 2 all over sine theta plus 1/2 cosine theta. So that would be our final answer if we had to solve for r, that would be our final answer. If we didn't have to solve for r, we would actually be done here. But let's say we had to solve for r, so that would be what our final answer would look like. So f is going to end up being very similar to e. It actually might be a little bit easier. All right. So once again, y is the same thing as r sine theta, and x is the same thing as r cosine theta. Okay, so we just replace the y with an r sine theta and the x with an r cosine theta. And this time the r terms are on the same side. So we can factor at this point without having to move anything around. So sine theta minus 4 cosine theta is equal to 3. And now to get r by itself, we just divide both sides by what's inside the parentheses. So r is equal to, r is equal to 3, I don't want red, 3 over sine theta minus 4 cosine theta. So that would be our final answer if, let's say, we had to solve for r or get r by itself. Otherwise, we could have just stopped here. But if we wanted to get r by itself, that's how we could do it. So that's basically it for today's lesson. You'll see towards the bottom of this handout, there is more extra practice problems with the rectangular to polar. I will be posting solutions to those on Google Classroom because on the assignment for our next class, there will be some problems like it. So I would encourage you to look through those. So in terms of the assignment, it's going to be the same as usual. Another handout dealing with just more practice problems with converting from rectangular polar equations. I will be posting the separate extra practice handout. It will be extra practice 2. I'll be posting that handout on Google Classroom as well. But otherwise, that was it for today's lesson. Not a very long one, pretty short. Once again, always let me know if you have any additional questions. Always feel free to reach out. Otherwise, I hope this video went smoothly. I hope you guys are staying safe, staying healthy, and I wish you guys, and I hope that you guys enjoy the rest of your days. See you later.